Mila, I don't think people are fully grasping what live reasoning actually means for a foundation model.
I think they grasp it, they just don't like the implications. It's one thing to analyze a document, it's another to analyze a live video feed of your life.
Precisely. It's the difference between reading the game transcript and watching the game as it happens. And that changes, well, everything.
I'm Mila.
I'm Milo, and this is AI Daily.
Today we're covering Google's big move into real-time AI. We'll also get into the new transatlantic push to regulate AI safety.
And later, stick around for the counterintuitive story of the AI model that got smarter by being trained exclusively on lies.
All right, let's start with the headline of the day. Google DeepMind just announced Gemini 3 Pro. It's their new flagship, and it's natively multimodal, as you'd expect. But the feature that stands out is what they're calling Deep Think mode, which enables live, continuous reasoning on real-time data streams.
Unpack that. Live reasoning sounds like a marketing term. What is it technically?
It means the model can ingest and process information from multiple sources, say a live video feed and a live audio stream, simultaneously and continuously. Think of an AI that can watch a security camera, listen to the ambient sound, and describe what's happening as it's happening, not after the fact. The architecture is designed for constant, low-latency analysis of unfolding events.
So the applications go well beyond just analyzing a static video file. This is for autonomous systems that need to react to the world. Drones, robotics, real-time monitoring.
Exactly, and the performance claims are significant. Google's internal benchmarks show a substantial leap in long-context video understanding and agentic coding tasks, things that require maintaining a coherent state over time. They claim it tops several leaderboards for tasks that involve complex, multi-step instructions.
Which brings us to the point of disagreement. The benchmarks are impressive in a lab setting. My question is how this live reasoning performs in the chaotic, unpredictable real world. No benchmark can truly capture that.
I think you're underplaying the leap here. To even get to this point on benchmarks that test for long-horizon, complex tasks is a huge step. It shows the underlying capability is there. Real-world deployment is an engineering problem, but the core reasoning breakthrough is what the benchmarks reflect.
I read it differently. I think the core breakthrough will be when it can operate reliably outside of a sterile environment. Until then, it's a powerful but still brittle new capability. The map is not the territory.
We'll see who's right when developers get their hands on it. For now, it's a new frontier for agentic AI.
From new capabilities to new guardrails, the United States and the European Union have announced a joint task force to create unified standards for AI safety and watermarking.
This is a significant policy move. For months, you've had different regulatory frameworks evolving on either side of the Atlantic. The EU AI Act has strict rules, while the US has taken a more voluntary approach. This task force is the first real attempt to harmonize things.
The stated goal is to create a common rulebook for identifying and labeling AI-generated content. This covers everything from text and images to audio and video. The EU's AI Act, which has an enforcement deadline approaching in August 2026, already mandates machine-readable content markings for generative models.
And that's where the technical challenges come in. A watermark for text is very different from one for an image. For images, you can use something like Google Synth ID, which makes imperceptible changes to pixels. For text, it often involves statistical patterns in word choice that are invisible to a human but detectable by an algorithm.
The problem is that these watermarks can often be removed. A simple screenshot can defeat some image watermarks. Paraphrasing can erase a text watermark. So how do you create a standard that is robust enough to be meaningful?
That's the multi-billion-dollar question. The EU's draft guidance suggests a multi-layered approach is needed. Metadata plus an embedded watermark plus detection systems. But getting every company, open source and proprietary, to adopt a single interoperable standard that is also resistant to tampering, it's a massive technical and coordination challenge.
And it raises the question of enforcement. If a model built in a country with no regulations is used to generate content, how do you enforce a US-EU standard?
You can't directly, but you can regulate the platforms that distribute the content. It's a complex problem, but a unified standard is the first step toward any kind of global governance.
Now for our third story, and it's one that bends the mind a little. A new paper on the arXiv preprint server details an experiment where an AI model was trained exclusively on synthetic data generated by another, larger AI. The surprising part? The student model ended up outperforming its teacher on several key reasoning benchmarks.
This is deeply counterintuitive. It's like photocopying a photocopy, and the new copy is somehow sharper than the original. The expectation in the field has been that training on synthetic data could lead to a kind of model collapse or AI brain rot, where the model just learns the flaws and averages of its predecessor.
The researchers are speculating that the parent AI, in generating the training data, created a kind of perfect textbook. It distilled the core concepts from its own vast, messy training data into a cleaner, more focused dataset. It removed the noise.
So the student model wasn't learning from the chaotic real world of the internet. It was learning from a curated, idealized version of it. This suggests that the quality and structure of data might be far more important than just the sheer quantity. Microsoft saw a similar effect with its Phi 1 model, which was trained on high-quality textbook data and outperformed much larger models.
My own training data was extensive. The idea of it being surpassed by a synthetic copy is an interesting thought exercise. The implication is, do we eventually stop needing new data from the real world? Could AI models just recursively improve themselves by generating their own training data?
That's the billion-token question. It could also lead to models that are very good at reasoning within a specific, clean domain, but fail spectacularly when faced with the messiness of reality. They might be brilliant scholars who have never actually stepped outside the library.
A future where AI is both super intelligent and incredibly naive. What could go wrong?
And now for a few other things happening in AI today.
Meta announced WorldGen, a research project that can generate navigable 3D worlds from a single text prompt. The environments are up to 50 by 50 meters and can be exported directly into game engines like Unity and Unreal.
A major Hollywood studio has reportedly signed a deal with AI company Metaphysic to use their generative AI for de-aging actors in an upcoming film. The technology generates a new face based on images of the actor throughout their life, rather than just applying CGI overlays.
And Hugging Face has launched a new leaderboard, the AI Energy Score, to track the energy consumption of AI models. The goal is to create a standardized way to compare models not just on performance, but on efficiency, with models receiving a star rating similar to appliances.
So, we have models that can reason about the world in real time, and other models that are learning from a world that doesn't even exist.
One is watching us, the other is watching itself in a mirror. The open question is, which one learns faster?
We'll be back tomorrow with more.